about the upcoming.
We did not have to travel far to get
eclipse.
to the Second Baptist School here in Houston. It just went right up the road from our TV station, so it was nice that we weren't on the road very long. It's the closest visit we've had, and I've got some special fifth graders to introduce you to. Would you guys all say hi to our audience? We are really excited. Of course, we are less than a week away from the total solar eclipse. And I have to tell you a story. I got this invitation to do this particular talk, to talk about the solar eclipse at the beginning of the school year. And the teacher asked and said, Anthony, would you please talk to us about the solar eclipse, and would you make it as close to the date as possible? And I'm like, well, I got the Wednesday before open, and that's why I'm here with you. So today, what I'd like to do is talk to you about the total solar eclipse. And this is when the moon completely covers the sun, and we at this time fall into the moon's shadow. So on April 8th, on Monday, for us in Houston, we are going to have a partial eclipse. 94% of the sun will be covered, but that is not totality. Totality is when the perfect shadow of the moon goes over the face of the sun, and for that place, it's here in Texas, but you have to make a drive. And I know a lot of you were talking about how if the weather works out, you're going to be outside your school and you're going to see the partial solar eclipse. My plan is I'm going to be right about here in Fredericksburg along the center line, hoping to see it if the weather works out. So what I want to share with you here is I'm going to turn on the audio. You might have two channels of audio. Listen to the reaction of people who see totality. So you had two channels of audio, but you could hear the excitement, because you're actually seeing something, and more than seeing something, you're experiencing something that you've never witnessed before, and you're seeing, this is, again, a video, you're seeing the sun's corona. Typically, we can't see the sun's corona because the sun is too bright. But the corona is 2 million degrees. The outside of the sun, the outer atmosphere of the sun is 2 million degrees. The surface of the sun is 50,000 degrees. And it's a lot hotter, and you're seeing this incredible view. It gets dark around you. Along the horizon, you can see sunsets in all direction, and it's a pretty incredible experience. But what's the difference? So for us, if we're in Houston, we get a partial eclipse. In October, we had an annular eclipse, and now we have a total eclipse. So we have solar and then also lunar eclipses. First of all, solar eclipses are incredibly rare because the moon is small, and you can see it pass in front of the face of the Earth here. So there it goes, and your shadow is small. And that's why we're not seeing it here in Houston. We get a partial eclipse, and then it goes over the Earth. Now, lunar eclipses are common. And the reason they're common is because the Earth is a lot bigger than the moon. So as it goes around, it speeds up. Look how much bigger the Earth's shadow is compared to the moon shadow. Much bigger. So these are a lot more common, and there it goes. So that's the difference between a solar and a lunar eclipse. The sun's always out here. But how does this happen? So we all have this either in our classrooms or we've seen a book like this. So here's the sun, here's the Earth, here's the moon. We all know, I think, right, being fifth graders, that the Earth travels around the sun. How long does it take the Earth to travel around the sun? The Earth to go around the sun? 365 days. 365 days. Now, 24 hours is this. It takes 24 hours to rotate. There's 24 hours, okay? At the same time, the moon is traveling around, now this is kind of hard to do, but the moon is traveling around the Earth at the same time. If this were real, and we kept this sun the same size, this would be 50 feet down there, and it would be the size of an O on your keyboard. If we kept the Earth the same size, this would be the size of 29 feet in diameter, so basically as tall as the roof, and it'd be a half mile down the road. So to get some perspective on this, you have to realize that this isn't really how it matches up. But that's how it happens. The moon gets between the Earth. But what you have to understand is the way the moon moves. It's not a perfect rotation around the sun. So there are times that the moon is actually farther away from the earth, and there are times that the moon is closer to the earth. When it's farther away from the earth, it's called apogee, far, and that's Latin for far. So when it's at apogee, you get a ring around the sun like we had in October. When it's at perigee, when it's close to the earth, we get a total solar eclipse. So this is what I saw October 14th of 2023. It was an annular eclipse. I was in Albuquerque, New Mexico. Annular eclipse does not mean annular, like annular, and an annual, like an annual sale. Annular means it's Latin for ring around the sun. But what's incredible about this, and this is really what I think is fascinating for where we live, speaking of the earth, the moon is 400 times smaller than the sun, but the sun is 400 times farther away, which means in the sky they appear exactly the same size. And when they line up, the moon completely blocks out all the light from the sun. How incredible is that? Let me show you how rare this is. I need two people to help me here. We're going to demonstrate the relationship, because we talked about how far away the earth is from the sun. Come on up. Now let's get a boy. Come on up. You're to be the moon. Okay? What's your name?
Brooks Kelly.
Brooks. Okay, Brooks, you're gonna be the moon, all right? Just hold it for right now. What's your name?
Shay Salem.
Shay Salem's gonna be the earth, okay? Shay, everyone say hi to Shay. You're the earth, all right? We're gonna do this. Shay, we're gonna come over here. Brooks, you stay still. Okay, Shay, keep walking over here. You're gonna walk with me here. Okay, we're gonna show how far away the moon is from the earth. Go ahead and walk. Brooks, go walk, keep walking. Be careful, don't hit them. Keep walking, keep walking, keep walking. Keep going. Keep going. Oh, good. You know what you're doing. You're not going to trip. Right? Keep going. Keep going. You can go a little faster if you want. Stop. How far away is the moon from the earth? So do you see how it's tough to get that perfect shadow right over the earth? I mean, that's pretty far away. But now there's something else. Give them a big round of applause. Thank you, Brooks. Put that down here. So here's what we were asking. You had somebody ask this question before we started. Why don't we get a total solar eclipse every month, no matter how far away the moon is? Shouldn't we get a total solar eclipse once a month if indeed the moon travels around the earth this way? Okay, and I said, who has the answer to this question? And a bunch of you guys raised your hand. So, come on up if you know the answer. That's good. 4 people's enough. 4 people's enough. Okay, really good. Okay. Why don't we have a total solar eclipse every month if that's the way the moon revolves around the earth and the earth goes around the sun? What's your name?
Kate Eustace.
Okay, Kate.
Because the earth rotates around, so
Okay.
the moon's not going to be in the same place like every month.
Correct. But let me show you this. That's correct. But so the earth is rotating. You got that part right. But the moon's going like this. Shouldn't someplace on the earth get a total solar eclipse every month? Shouldn't that happen? They happen on average once every 18 months. So it's not about the rotation of the earth, but good guess. Okay, second one, let's see. Why?
Is it because the moon is smaller than the sun, and the moon doesn't travel in like a perfect orbit?
Okay, good. It is smaller, so this captures that. It's smaller. It's not a perfect orbit, it's an ellipse like we talked about. It's not a perfect circle, but still even smaller somewhere on the earth, because it's lining up every month, right? Somewhere on the earth should get a total solar eclipse once a month. But no. Good guess, though. You guys are smart, because those are all really good guesses. Yes.
Okay, so
you got this, I can tell.
So the moon has to align with the earth because the moon isn't in a perfect orbit with the earth.
Big round of applause. What's your name?
Beckett Henderson.
Everyone look up here with me. This is what Beckett is talking about. The moon doesn't travel around the earth in a perfect, even if it's an ellipse, in a perfect rotation. It's not flat. It is tilted. So There's a 5-degree tilt that the moon goes around the earth in. And because of that 5-degree tilt, there are times that the shadow does not even get close to the earth. That's why it's rare. Once every 18 months, on average, do we get a total solar eclipse. In fact, next year we don't have one at all. Our next total solar eclipse isn't until the year 2026, and then there's another one, 2027. If you get to be in the path of totality with clear skies, you'll see what's called the diamond ring effect. Does this look like your teacher's rings if she's married? The sun's corona, we talked about that. You see Bailey's beads. What's incredible about Bailey's beads is that what you're seeing when the moon first crosses the complete face of the sun, or right about when it's about to leave, at that time frame, you're actually seeing with these beads the mountains, the valleys, the undulation of the moon, and the sun's light is peeking through all of that, which is pretty incredible. You see prominence in chromosphere. The chromosphere is that pink edge, and prominences are those little flares coming off the face of the sun, which again, with good binoculars or a telescope, you can see, and if you're in totality, you don't even need the glasses. So how rare is a total solar eclipse for Texas in the United States? The last Texas eclipse was in 1878. 1900 was one also, but it was just barely South Texas. The next American eclipse, 2045. Where you live, this spot, on average, if a total solar eclipse was to happen at this school, it would happen on average once every 375 years. This is what it looks like from space. There's the moon's shadow. That's pretty cool. That was April 20th from 2023. Went over Australia. And then October 14th, I was mentioning, I was in New Mexico. That little black dot, that's the moon's shadow. So the moon's pretty small when you were mentioning. That was a great answer. It is pretty small. What's cool is if you see totality and you look along the horizon, this is a picture with a fisheye lens. Do you see the colors around? That's every sunset at one time happening during the day. This is what it's going to look like here in Houston. If we look south, it's 67 degrees up on the horizon. So about looking at your chair, and you're looking at right about there, that's where the sun is going to be. But will it be clear? The partial eclipse times in Houston for Monday, 12:20 is when the partial eclipse starts. The maximum eclipse is at 1:40. That's when 94% of the moon, with the sun's face is going to be covered. And the partial eclipse ends at 3:01. So if we can get the clouds out of here and get the rain out of here, at 1:40 exactly, that'll be the maximum eclipse of the moon blocking out the sun. Thomas Edison in 1878 wanted to measure the sun's corona, what the temperature of the corona was. So he got what's called a tassimeter. He got a group of people and they set up in a chicken coop because it was relatively quiet, it's an enclosed place, and we're going to measure the temperature of the corona, which I mentioned is 2 million degrees. The problem is they didn't realize that animals react different in an eclipse. So when it got dark, all the chickens thought it was time to go to bed, so they all went to roost, and they all went in the chicken coop making a ton of noise, realizing people are in their space, and they went nuts, and his experiment failed. So we know Thomas Edison did some great things, but what he didn't do was measure the temperature of the corona. In 1919, Albert Einstein's eclipse. In the year 1914, Einstein came up with the theory of general relativity, which is that large objects, a large mass, will bend light because of its gravity. That was his theory of general relativity. And so in 1919, he had this theory. 1914, and then in 1919, it was actually tested. And what happened was they discovered that a large object like the sun will cause space or light to move, but they discovered this theory was true during an eclipse. How? Because the moon blocks out all the sun's light. We can't see stars right now, can we? So we have no idea where they are. At nighttime we see them, and we know like one star is right there. But at daytime we don't know where that star is. But if the moon covers the sun, will that star be in a different place if it's close to the sun? And what they found was that his theory was correct. So it proved his theory of general relativity, that the actual location of the star is here, but that's the apparent location of the star where it looked like during the day. So the sun actually did bend light. his theory of general relativity was proven in 1919, and it turned Albert Einstein from a real smart physicist into a legend, to where we all know him today. Don't look at the sun. You guys were all talking about this. Sunlight damages your eyes. There are safe ways to see an eclipse, and guess what? Can I bring up Anna up here? Anna, who invited us, we have a gift for you guys. This is for you and your school. We got you guys your own solar eclipse glasses. So if the clouds are away, so these are, thank you for inviting us. And these are for you guys for Monday. So let's hope the clouds aren't here. But this is my family and I, we were in Oregon and seeing the last eclipse. And then some random shady kid that I just filled out the picture there. The eclipse in October was on a Saturday, so there were a lot of kids who made pinhole cameras, pinhole projectors, because they didn't have glasses. And so if the sun's over here, I look away from the sun. I put one little dot here, if you guys like Reese's Puffs, and you could actually see the partial eclipse here without looking at the sun. So that's a pinhole projector. The sun is 100 times bigger than the Earth. The sun is 93 million miles away from us. It takes 8 minutes and 20 seconds for the light to reach us. So we're always walking around an old light. So when you see the very last of the sunset, did you know that that light from the sun has actually been gone for 8 minutes and 20 seconds? So how I forecast the weather, and you have 3 special students who are going to do some solar eclipse forecasting for us. First of all, I have radar. I have satellite. I have recording stations. So here at your school, I know what the temperature is. I know what the wind speed is, what the relative humidity. By the way, on the radar, if you ever see a hook like this, that is very bad. That's a hook echo. That would indicate a radar-indicated tornado. I have surface maps, where high pressure, where low pressure is. I have models. So both the American model and the European model both have rain here on Monday. So we'll remember this. This is going to be important because we're going to see if these models were correct 5 to 10 days out and what changes. I also look outside. If the rock is wet, it's raining. If the rock is swaying, it's windy. If the rock is hot, it's sunny. If the rock is cool, it's overcast. If the rock is white, it's snowing. If the rock is blue, it's cold. If the rock is gone, tornado. And then I make the graphics. And I get in from sometimes a green screen like your students are going to do. And then I do a forecast. So now it's your turn. You're going to do the weather for your city. And on top of that, we have Hogan, who is going to do the forecast for the total solar eclipse. So the question was at the beginning, what's the weather going to be like? Hogan's actually going to answer that question. Can everyone give a big round of applause to Hogan for being brave and being the first one? Hogan, when you see yourself there, go ahead and start. Don't start until you, okay, yeah. And wait, when Roger's ready for you, you're ready to go. And then your students are going to see you do it live. Okay, whenever you're ready, Hogan.
Hello, I'm Hogan Hermes, and I'm a 5th grader here at SBS. Today, it is 61 degrees outside with the sun fully out. We have a humidity of 54% and the wind at northwest with 12 degrees. 24-hour change is -12. This will be the weather on the day of the eclipse. As you can tell, in Houston, it will be raining. If it does rain or the clouds do come out, we will not get to see our eclipse. This is what the eclipse will look like if there's no clouds or rain. If the eclipse doesn't happen, this is what it will look like. The partial eclipse begins at 12:20. The maximum eclipse for Houston will be exactly at 1:40, and the partial eclipse ends at 3:01.
Good job. That was excellent. Okay, who do we have? Okay, and when he gets in position, you're ready to go.
Okay. Hi, my name is Maddie Gardner. I'm a 5th grader at 2nd Baptist School. The weather for today will be 61 and it will be sunny. The humidity will be 54%. The wind will be northwest with 12. It will be 12 degrees colder than it was yesterday. This is what it will be like on Monday for the eclipse. Hopefully it's not too cloudy so you can still see it. As you can see, it will be raining. So if it rains too much, we probably won't be able to see it, but hopefully we can see it. If there are no clouds, this is what it will look like for the partial eclipse on Monday. This is what it will look like if the weather is like that. The partial eclipse begins at 12:20 p.m. and we will be outside to be able to see it. The maximum eclipse is at 1:40 p.m. The partial eclipse ends at 3:01 p.m. Thank you so much for listening.
Hi, my name is Mackenzie Dunn, and I'm a 5th grader at Second Baptist School. The weather today will be 61 with sunny. The humidity is 54%. Northwest wind 12 degrees. 24-hour changes is negative 12. It is going to be a little rainy on Sunday. As you can tell, it's going to be a little rainy on Monday too, so we hope we can still see the eclipse. This is what the partial eclipse will look like if it is not raining. This is the clouds if it is raining. We hope we can still see the eclipse. The eclipse begins at 12:20. The maximum eclipse begins at 1:40, and the partial eclipse ends at 3:01.
Excellent job. Excellent job. Come on up. Everybody come on up. Oh, no, the 3 kids. Sorry. Okay, so I need Hogan, Mackenzie, and Maddie. So, first of all, I've got to be honest here. I've done this. We've done this, right? All school year long. Did this group of kids do better than any other kids as far as being smooth, articulate, and just knowing what the story was?
Everyone except one girl.
Everyone except one girl? Yeah, we had one amazing girl that was incredible, but never a whole group like this. So what did you guys think? I want to hear what you guys thought of the experience, because again, that was live. There was no way that you could stop and say, wait, I want to do this again. What did you think?
It was really cool
It was cool?
and fun.
It was fun? Was anyone nervous?
Yes.
You were all nervous, really? Now here's the thing. For me, being nervous, I'm more nervous about the forecast, because usually when I give a forecast and I'm like, it's going to rain off and on Sunday through Wednesday, that's not a big deal. But the big deal is because this is such a big event for the solar eclipse, the partial eclipse for us, the path of totality for Texas, is that we're being so specific for clouds. I'm never forecasting clouds as far as being specific and people caring. So I'm nervous that if it really is bad, there are people who spent a lot of money to travel to Texas to see the eclipse, and they're going to possibly see the clouds that your students showed you. So that's tough. But hopefully, and this is a good lesson too, the closer you get to a forecast, the more it changes, or it doesn't change. But the closer you get, you get a better idea of what exactly is going to happen. So we're talking about something that's 5 days out. So there are still some things that can happen that might be better for us. We'll see. So we're all going to see what happens on Monday, because clouds are important more than even just rain. So one more big round of applause. Okay, we do have, I think, 2 or 3 minutes left. 2 minutes left. So I think I got time for maybe 1, 2 questions. Come on up. Quick. What's your name?
Colt,
Colt, what's your question?
what is the significance of a solar eclipse?
Isn't that a great question? What is the message of a solar eclipse? What do you think?
The moon is blocking the earth.
Yeah.
The sun.
But is there a bigger message than that? Is there something, you think about how this has been around since the earth, the moon, and the sun have been around, and these eclipses have stopped wars when they happen because people didn't know they were coming. They've been able to be predicted because there's called a sorrow cycle. but now you can do it with math, but before you could do it then. What is the bigger message of a solar eclipse? That's something I want you to think about. Is there a message? Is it just the moon passing in front of the sun? Or is it something more special than that? Yes, come on up real quick. Last question. I think we have 1 minute left. What, you got to run or you're not going to get your question in? All right, you jogged. That's okay. What's your name?
My name is Dylan Harvey.
Dylan, what's your question?
How far does the shadow range?
How far does the shadow range? For us, it is 124 miles. 124 miles wide. And again, that depends on how far away or close it is to the Earth. With my eclipse that I saw in 2017, it was only 94 miles wide. So it was smaller because the moon was slightly farther away. But ours is 124 miles, and then it becomes a partial eclipse for the rest of the United States. Okay, we have one, maybe a little bit more. Okay, come on up real quick. And when we run out of time, I'm just going to have you guys say goodbye, and you're going to wave to Roger, okay? And everyone watch Renee, because he's going to count us down from 10, and then we just wave. Go ahead.
What is the rarest solar eclipse?
Ooh, the rarest?
Yeah.
They're all rare. I guess when you think about it, it's like, where does it go over that's cool? I think the one that is in 2027 that goes over Luxor, Egypt, that goes over the Sphinx and the pyramids, it's at 88 degrees up in the sky on the horizon, and it's going to be dark for 6 minutes and 23 seconds. That one's kind of really cool, but this one's cool because it goes over from Texas to Maine. In 2017, the one went over the entire United States from Oregon all the way out to South Carolina. And then the one in 2045 goes from Northern California through the state of Florida. So those are cool because they're the United States and it's where we live. So, yes, we still got time. Come on up, quick. Again, once we get a countdown. Okay, everybody wave, say goodbye.